Let's look at another example of using Riemann sums to approximate area between curves. So let's use the same function y equals x squared plus 1. We're going to approximate the area between that function and the x-axis. This time let's pick a different interval. So we're going from -2 to 3, and we're going to use 5 rectangles. So these are the main things we need to pick out from the problem, and the fact that we're using right endpoints is going to come into play when we choose our sample points. Okay, so maybe let's write our information down. So A is going to be -2, B will be 3, N is 5. So this is everything we need for delta x, and then when we compute the heights, we'll need to know that f of x is x squared plus 1. Okay, so let's do delta x. So delta x always is b minus a over n. B is 3 minus a is -2 over n, which is, 5. So 3 minus -2 is 5 over 5. So the width of each rectangle will be 1. And you can sort of see that if you think about it, the length of this interval should be 5. And if we use 5 rectangles over a length of 5, they all should have a width of 1. Okay, so we're going to use right endpoints of my intervals. So first, maybe let's look at a picture and draw in our intervals. So each interval starting from -2, our starting place will be 1 wide. So there's one of them. The next one will go from -1 to 0, then from 0 to 1, then from 1 to 2, then from 2 to 3. And so these are the bases of the rectangles, then we got to find the heights. So the right endpoints are going to be the right side of each interval. So C1 is actually equal to -1 in this case. C2 is 0. C3 is 1. C4 is 2. And C5 is 3. And notice these are the right endpoints of each of these intervals. These aren't the heights. These are what we're going to plug in for the heights. So we have to plug it in to our function, which is x squared plus 1. Oops. So plug that in. Plug in 0. Plug in 1. Plug in 2. And plug in 3. Okay, so this will give us our heights. -1 squared is 1. 1 plus 1 is 2. 0 squared is 0 plus 1. This will be 2 again. This is 4 plus 1 is 5. And this is 9 plus 1 is 10. So this is the height of our thing, height of each rectangle. So each rectangle has these heights. So these are our 5 rectangle heights, and this is the width of each one. So it would be 2 times 1 plus 1 times 1 plus 2 times 1 plus 5 times 1 plus 10 times 1, which, again, we could just do the heights added together since all the widths are the same. So 2 plus 1 plus 2 plus 5 plus 10, and then multiply times 1, which won't change anything. So what do we get? So this is 5 plus 5 is 10 is 20, so the answer should be 20. So if we were measuring this in inches, then we would have 20 square inches, right? And let's go back and think about, so if we use the right endpoints, all the heights will be on the right side of each interval. And the area we just found was the sum of the area of these rectangles.